Hello students, wish you a very happy new year. I am Dr.R. Professor, Department of Mechanical Engineering, RBS College of Engineering, Tindikal. Already I have posted 3 videos on MCQs for the subject robotics. This video describes the unit 4, the robot kinematics and robot programming. So we will go into the video, the MCQs for the 4th unit of the subject robotics. So unit 4, robot kinematics and robot programming. As I already mentioned, there are 2 parts in your non-university MCQ pattern. One is part A and part B. So in part A, the question 1, forward kinematics is A. Deriving the position and orientation of the end effector from the joint angles and link parameters. Question B. Deriving the joint angles of the manipulator from the link parameters and position and orientation of the end effector. C. None of the above. So forward kinematics is deriving the position and orientation of the end effector from the joint angles and link parameters. So answer is A. Question 2. Reverse kinematics is A. Deriving the position and orientation of the end effector from the joint angles and link parameters. B. Deriving the joint angles of the manipulator from the link parameters and position and orientation of the end effector. C. None of the above. So reverse kinematics is deriving the joint angles of the manipulator from the link parameters and position and orientation of the end effector. So the answer is P. So we know the difference between what is forward kinematics and what is reverse kinematics. So in kinematics, mostly we have derivations and equations. So obviously they can be asked in the part B section. So we will discuss in deeply in the part B sections about the kinematics. Question 3. In power lead through programming, which one of the following is used for programming? A. Robot arm. B. Teach pendant. C. Textual programming. In power lead through programming, teach pendant is used for programming. So answer is B. Question 4. In manual lead through programming, which one of the following is used for programming? A. Robot arm. B. Teach pendant. C. Textual program. So the answer is A. So in manual lead through, it is by moving the robot arm itself, we are going to teach the robot the path. In power lead through programming, the path the robot has to move, that is taught by a teach pendant. So that is the difference between manual lead through programming and power lead through programming. Question 5. In offline programming, which one of the following is used for programming? A. Robot arm. B. Teach pendant. C. Textual arm. So C. Textual program. Answer C. So previous 2 are called as, that is manual lead through programming and power lead through programming are called as online programming methods. The textual programming, that is called as offline programming. So answer is C. 6. Power lead through programming is more suitable for A. Continuous path programming. B. Point-to-point programming. C. Both. Power lead through programming, we are using a teach pendant to teach the robot. It is more suitable for point-to-point programming. Answer is B. 7. The downtime loss is eliminated in which one of the following programming method? A. Manual lead through programming. B. Power lead through programming. C. Offline programming. Answer is C. The downtime loss means during the programming the robot is not operated. So that is called as downtime loss. So that will happen only in manual lead through programming and in power lead through programming. So in both the cases we need to teach the robot or we need to program the robot while the robot is not in operation. But in offline programming we can program somewhere else and then that can be downloaded to the robot. By that the robot can be operated. So the downtime loss is eliminated by the offline programming method. Which one of the following is the definition of point in valve programming? A. It is A1. B. Here A1. C. There A1. So it is A1 and there A1 are the wrong answers. B is the right answer. Here A1. Moves P is the command used for move to point P sharply. B. Move to point P in straight line. C. Move to point P simply. So the answer is B. Move to point P in straight line. So in any programming, if S is added, then that movement must be in straight line. That is what actually the moves. Move is the move command and the S is added to move to that particular point in a straight line path. Answer is B. Question 10. The end effector to be moved to the vicinity of A1 but offset from the point along the z-axis above the part by a distance of 50 mm. The command is A. Depart 50. B. Approach 50. Approach 50. C. D. Move 1, 50. Okay. So the answer is B. Approach 50. The end effector to be moved to the vicinity of A1 but offset from the point along the z-axis by a distance of 50 mm. The command is approach 50. So the depart is, and the approach is used when the end effector approaches the object, and depart is used when end effector is moving away from the object. So both are going to be in an offset from a point along the z-axis, but the difference is for approach and depart. The approach is for when the end effector is approaching the workpiece, and depart is for when the end effector is moving away from the workpiece or at the particular point. Okay. So D move is, it is a small move or an incremental move. Usually when you are saying incremental, we are calling it as dx, dy. Like that, this D move means an incremental move, right? So in incremental move of 1 from the point actually 50. So like that actually, this is an incremental move, D move means. Question number 11, the command speed 60 indicates A. Speed is 60 inches per second. B. Speed is 60 RPM. C. Speed is 60% of the normal speed. So answer is C. If it is given simply 60 alone, then it is called as 60% of the normal speed. Okay. So it is mentioned as inches per second or RPM. Then it represents actually 60 RPM or 60 inches per second. But if it is represents in a plain way, that is speed 60, then it means the speed is 60% of normal speed. 12. Open and close are the two commands used for A. Opening and closing of the robot cell, opening and closing of gripper, opening and closing of CNC door in robot cell. So the open and close are the commands related to the robot operation. So they are used for opening and closing the gripper. Answer B is correct. So now we will move on to part B questions. Question number 13. Consider the forward transformation of a two-joint manipulator. Given the length of the link L1 300 mm and length of the second link L2 250 mm, the joint angles theta 1 is equal to 30 degree, theta 2 is equal to 45 degree. The coordinate positions of the end of the arm are A 356.5, 400.2, B 324.5, 391.8, C 338.6, 352.9. So only this answer can be found by doing some calculations. Without that directly we can't say A or B is correct. So the answer, how the answer comes, we'll see. The hint is for a two-joint manipulator, because it's a forward transformation, but we know the link parameters and the joint angles. From that we have to find the positions. Okay. So when you say position, we have to mention it by x, y values, because it is a two-joint, a 2 DOF manipulator we are considering. So here we have to consider x, y. So the value of x is equal to L1 cos theta 1 plus L2 cos theta 1 plus theta 2. So that is equal to 300 cos 30 plus 250 cos 30 plus 45. So you know what is the value of L1. L1 is 300, theta 1 is 30 and L2 is 250 and cos 30 plus 45, that is theta 1 plus theta 2, that is equal to 324.5. the answer is. So from finding the one answer itself we can give the value of B, but in some cases if 324.5 is given in two answers, then it will be a confusion. Okay. So Y, that is equal to L1 sin theta 1 plus L2 sin theta 1 plus theta 2. So 300 sin 30 plus 250 sin 30 plus 45, that is equal to 391.8. So thus 324.5, 391.8, that is the position. Okay, that is answer B. So again, question 14. Consider a two-joint manipulator. The length of the links L1 is equal to 300 mm and L2 is equal to 250 mm. The coordinate points of the end effector are defined as 399, 320. The joint angles theta 1 and theta 2 required to achieve the point A 19 degree, 43 degree, B 12 degree, 64 degree, C 45 degree, 60 degree. So the hint for this problem. So here it is reverse transformation. So the given is link lengths L1 and L2 and the coordinate points are the position 399 and 320. Then we need to find the joint angles theta 1 and theta 2. That is the question. We try to understand the question first. So because it is a two joint manipulator, the equation is for cos theta 2 x square plus y square minus L1 square minus L2 square divided by 2 L1 L2. So these equations are derived equations from the derivation. Normally for descriptive type the derivation is asked. So in this case we are going for MCQs. We need to remember the formulae, and then only we can easily apply the values and we can find the answer. So cos theta 2 is equal to x square plus y square minus L1 square minus L2 square by 2L1 L2. So cos theta 2 is equal to x square, x value is 399 square plus 320 square minus L1 300 square minus L2 square 250 square divided by 2 into 300 into 250. Okay, I put a dot actually, 2 into 300 into 250. So the answer is theta 2 is equal to 43.33. So theta 2. So theta 1 value, so tan theta 1 is equal to y into L1 plus L2 cos theta 2 minus x into L2 sin theta 2 divided by x into L1 plus L2 cos theta 2 plus y into L2 sin theta 2. So tan theta 1 is equal to y 320 into 300 plus 250 cos theta 2, you know, 43.33 minus 399 into 250 into sin 43.33 divided by 399 into 300 plus 250 cos 43.33 plus 320 into 250 sin 43.33. So the answer is 19.33. So the very closest answer we can see here is theta 1 is equal to 19 and theta 2 is equal to 43. So A 19 degree and 43 degree. Okay, so this is the answer. So remember, you have to remember all these equations, then only you can apply and you can get the answers easily. You can't do the derivations and all those things within the stipulated time. So you have to memorize these equations. Okay, there is no other go. So question 15, the world coordinates for RR:R as x is equal to 300 mm and y is equal to 400 mm and pi is equal to 30 degree, and given that the links have values L1 is equal to 350 mm, L2 is equal to 250 mm and L3 is equal to 50 mm. The joint angles theta 1, theta 2 and theta 3 are. So this is again three joint configurations. We can see from the coordinate system itself, it is RR. Okay, so we are having three joints actually. So the joint angles are theta 1 and theta 2, theta 3, that we have to find out. All the other values, the link parameters as well as the position are given, x and y value are given. So this is again, it is not a forward transformation, it is a reverse transformation. Okay, so the answer A is 25.2 degree, 35.9 degree, 56 degree. B 22.5 degree, 82.9 degree, minus 75.4 degree. C 20.5 degree, 72.9 degree, minus 65.4 degree. In the examination, necessarily not all the angles may be asked. The one or two angles may be asked. Okay, like that. So for reducing the time taken for a problem, so like that it may happen actually. But anyhow, you try to learn all the things and then you apply whatever is necessary in the examination. Okay, so here x3 is equal to x minus L3 cos pi. So x is given as 300. You can see here x is given as 300 and L3 we know it is 50 into cos pi value is 30, that is equal to 256.7 mm. Similarly, y3 is equal to y minus L3 sin pi, so 400 minus 50 sin 30, that is equal to 375 mm. So now we are coming to the theta values. So cos theta 2 is equal to x3 square plus y3 square minus L1 square minus L2 square by 2L1 L2. In two joint process, it is x2 square plus y2 square. So instead of that, here it is x3 square plus y3 square minus L1 square minus L2 square by 2L1 L2. So 256.7 square plus 375 square, these two values we already found, minus 350 square minus 250 square divided by 2 into 350 into 250, that is equal to 0.123. So theta 2 is equal to 82.9. Then we are coming to theta 1 value. Theta 1, tan theta 1 is equal to y3 into L1 plus L2 cos theta 2 plus x3 into L2 sin theta 2 divided by x3 into L1 plus L2 cos theta 2 plus y3 L2. So here we apply the values. Y3 is equal to 375 into 350 plus 250 sin 82.9 plus 256.7 into 250 into sin 82.9 divided by 256.7 into 350 plus 250 cos 82.9 plus 375 into 250 sin 82.9. That is equal to 0.4146, what we are getting. From that, the theta 1 value is 22.5. So we are getting an answer that is 22.5 theta 1 and theta 2 is 82.9. So 22.5 comma 82.9. So that is theta 1 and theta 2 values. So where that this 75.4 minus 75.4 comes actually. So pi is equal to theta 1 plus theta 2 plus theta 3. So if you are subtracting from pi the theta 1 and theta 2 values, then you will get actually minus 75.4 degree. Okay. So pi is equal to theta 1 plus theta 2 plus theta 3. From that we can calculate theta 3 value, that is equal to minus 75.4. So now question number 16. This is again a 4-jointed robot. The links and joint of a TRL-R manipulator has the following settings. Length of the link L1 is equal to 250 mm. Length of the extension link L is equal to 375 mm. Length of the link L4 is equal to 75 mm. Base angle theta 1 is equal to 0 degree. Elevation angle theta 2 is equal to 20 degree. Pitch angle theta 4 is equal to 34 degree. The coordinates of the resulting point P are A 213.4, 543.9, 222.1, B 78.9, 122.3 and 420.19, and C 414.56 plus 0.420.19, 420.19. Okay, this is the question. I'll recommend one thing. Actually, before going to this MCQ, please go through the derivation once. Then you will understand how what are all the values actually, what are the link values, what is L1, what is L2, like that. So I'll recommend actually robotics by Dale for your reference. If you can get it, actually please go through that one before going into the problems. Actually, if you go through the derivation part, then you will understand what is it actually. So instead of saying L1, L2, L3, what L is, what L1 is, what L2 is, so that you come to know. So please refer the book. I think it is Robotics by and Automation by Dale, D-E-B. The author name is Dale. Okay. So answer A is 213. Okay, we have seen the answer. Now the hint we can go through. X is equal to L cos theta 2 plus L4 cos theta 4 cos theta 1. Here instead of two values, because this is going to be, we are going to find out the XY values, the forward transformation. All the angles are given, that is base angle, elevation angle, pitch angle, all those angles are given. But why we are taking 3 values, X, Y, Z values? Because it is a 3 degrees of freedom problem. So they have given 3 X, Y and Z axis actually, positions actually. So X, Y, Z and X, Y and Z values. So we have to take X is equal to L cos theta 2 plus L4 cos theta 4 into cos theta 1. So you substitute the values. L is equal to 375, cos theta 2 is 20, that is elevation angle, 75 cos theta 34, that is a pitch angle, into the base angle cos 0, that is equal to 414.56. Y is equal to L cos theta 2 plus L4 cos theta 4 sin theta 1. So the same thing, 375 cos 20, 75 cos 34 sin 0, that is equal to 0. So because sin 0 is 0, so all these terms becomes 0. Z is equal to L1 plus L sin theta 2 plus L4 sin theta 4. So Z is equal to 250 plus 375 sin 20 plus 75 sin 34, that is equal to 420.19 mm. Okay, so the answer is going to be 414.56, 0, 420.19. That answer is C. C is the answer. Question number 17, for the vector V is equal to 25i plus 10j plus 20k is translated by a distance 8 in the x direction, 5 in the y direction and 0 in the z direction. The new coordinate values are. A translation is from one point to other point, that is simple addition actually, matrix addition. So if you are taking it as 25, 10 and 20, so this is xi plus yj plus zk, that is the meaning actually. So you have to add them. So 25 plus 8, that is equal to 33, and 10 plus 5, that is equal to 15, and 20 plus 0, that is equal to 20. So 33, 15, 20, that is actually answer B. Okay. So question number 18, a vector B 3i plus 2j plus 7k is rotated about 60 degree about the z axis of the reference frame. It is rotated by 30 degree about x axis of the reference frame. The final coordinate values after transformation are A 0.1, 3, 9, 3.9, 7.2, B 0.2, minus 9.7, 6.2, C minus 0.1, minus 3.9, 6.22. So we'll see the hint now. So this is actually the rotation matrix. This is with respect to or about the z axis. So here h1 is equal to r z, 60. That means actually the rotation is about z axis at an angle of 60 degree. So the thing is cos theta minus sin theta 0 0, sin theta cos theta 0 0, 0 0 1 0, 0 0 0 1. This is for z axis. So this is cos 60 minus sin 60, sin 60 cos 60. Okay. And h2 is rotation about x axis for an angle of 30 degree. So this matrix is going to be different. 1 0 0 0, 0 cos theta minus sin theta 0, 0 sin theta cos theta 0, 0 0 0 1. So instead of theta we are substituting the value of 30 degree, right? So what about if it is not, if it is given as y axis, what is the thing? So the same thing we have to do. This is 1 0 0 0. This is the same actually. Here it is going to be cos theta. This is 0. This is minus sine theta. So remember, this is cos theta. This is 0. This is minus sine theta. So this column is going to be 0, 0, 1, 0, right? 0, 0, 1, 0, right? And this column again we need, actually this is going to be sine theta. This is 0, this is cos theta, this is 1. Okay, so this is sine theta, 0, cos theta, 1. This is for y-axis. Okay, y-axis is not given in this problem. So we are having two rotations. So the first rotation occurs in the 60 degree and second rotation occurs in the 30 degree in the x-axis. So we have to do a concatenated matrix, right? So H2, H1. So which one happens first? That should be kept at right, and then which one happens at the second, that should kept at left. Okay, this is what we are calling it as concatenated matrix. Okay, so this values cos theta minus sin theta, that values we are keeping it here, and we are keeping the H2 values here. Okay, so now we have to multiply this both matrices. Okay, so that will give you the value of H. So this concatenated matrix is to be multiplied with our vector. Okay, reference vector, that is 3i vector plus 2j vector plus, as I already told you, this is xi plus yj plus zk. So 3, 2, 7, 1. So that will give you the value of minus 0.1, minus 3.9, 6.22. So this is going to be minus 0.1, minus 3.9, 6.22. So the answer is going to be C. Your question may be like this. So whether the MCQs are so complicated because more calculations are needed. So you please understand these MCQs. Maybe only one rotation is given and you have to do that. So that simple calculations may be there. But if you understand these questions, what is for Z rotation, what is for X rotation, then you can apply it for any kind of problem. Okay. So I hope this video is much useful to you. Thank you. This year may be a prosperous year for us. So good luck to every one of you. Prepare well for the examinations and write your examinations, forthcoming examinations in a better way. Thank you.